Hello, this screencast is on electron configurations, and hopefully you've watched a screencast on doing quantum numbers because some of that information will be very helpful for you when we get into electron configurations. Alright, so a couple of rules for electron configurations. The first is that Hund's rule says that each orbital will fill up with one electron before doubling up, like a bus. People will fill up empty seats before sitting with someone. So this is like if you get on mass transit and you have a choice between sitting with the axe murderer or sitting in your empty seat by yourself. You're probably going to sit by yourself. So electrons will fill up each orbital first with a single electron before going back through and doubling up with a second electron. Aufbau principle says that electrons will occupy the lowest energy level possible. Okay, so when you're walking up a ladder or climbing up a ladder, you start at the bottom and you go to the second rung and the third and the fourth and the fifth and so on. You don't jump from the ground state to the fourth rung and then go back to the second. You fill them up from the bottom. All right, so here is an example of the electron configuration for nitrogen. So if we look at it, we're going to look at it and see if we can make some connections. Nitrogen it's written as 1s2, 2s2, 2p3. All right, so let's jump here to the periodic table and see what we can make sense about. So nitrogen, 1s2, 2s2, 2p3. So here is nitrogen, and you will notice that it is in the second row. And you might notice that it's in the P section. And you might also notice that nitrogen has an atomic number of 7. So let's go back and look at this again. Let's go back and look at this again. And we will notice that you have 2p. And if you look at all these exponents and you add them up, you get 2 plus 2 plus 3 is 7. Okay, so how do you do electron configurations? Well, what you do is you will list all the elements that you pass through, starting with hydrogen down to the element you're looking for. You can add up all the exponents, and that will equal the atomic number. And you're going to use the first two quantum numbers, which are the row number and the section letter. Okay, so let's look at nitrogen again. If you come here to nitrogen, you're going to start up here at hydrogen, which is number 1, and we're going to list all the elements on our way down to the element that we're looking for. So starting at hydrogen, we are in row 1. This is letter S, and there are 2 elements, so 1s2. And then we have to continue on from atomic number 2 down here to 3. So we're in row 2, section 2, and we're going through 2 elements, so 2s2. We'll move on to the next atomic number, which is this group here. And we're in row 2, letter P, and we're going to go 1, 2, 3. So nitrogen is 2p3. Okay, so we, as you can see, I asked you to look at cobalt. So cobalt is CO, it's right here. So again, you start at the hydrogen at the beginning and you list everything from hydrogen down to cobalt. Now some of you in the back of your mind might be grumbling and thinking, oh my goodness, what if she assigns element number 112? Well, you're going to be writing for a while if you get assigned element number 112. But I promise you there's a pattern and there is a shortcut, and we will talk about the shortcut later. So if we're looking for cobalt, you will go 1s, and there were 2 of them, 2. Then we go over here, 2s2. Come over here, it's 2. Letter P, and there's 1, 2, 3, 4, 5. There's 2p6. Now we're down here at element Na, and this is row 3, s2, 3p6. Down here again, 4s2. Now, when you get into this yellow area, you need to remember that in quantum numbers we subtracted 1. So here we're going to, it's in the row 4, but we're going to subtract 1 and we're going to list it as 3d. This is section D. So 3d, 1, 2, 3, 4, 5, 6, 7. So 3d7. So let's go back and look at cobalt. So cobalt is listed as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7, and I've made a note here. Remember, you're still subtracting for the rows if you were in a row -1 or a row -2. Okay, so there is a pattern, and you might even say, well, look, nitrogen started with 1s2, 2s2, 2p something, and that's the same thing here. So yes, if you go to an element beyond cobalt, you're going to have this same leading portion and just tack on the new parts to it. All right, so if I asked you to do PT, so my suggestion would be get out your periodic table, go in and write down PT. I promise it's going to be worth your time. Try and get this right. My suggestion would be to pause this screencast after I give my instructions here, and you go and try PT on your own, and then come back and I'll show you the right answer, and we can see if you got it right. So go ahead and hit pause. All right, welcome back. Hopefully you've already done platinum, and I'm going to put up the answer, and then we're going to go look at the periodic table. So the answer is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, and 5d8. So those of you who are groaning, maybe you got something wrong. My guess would be it was that you missed this 4f14. How do I know that? Well, let's look at platinum. So platinum is here. It's also number 78. So you could go back and you could look at your listing here and see if you had 78 elements in there. My guess would be if you got it wrong, you probably have 64. Okay, so how do I know that you're missing 14 elements? You carry on, 1s2, 2s2, you work your way down, you manage to subtract 1 for the D section, you continued on, you're fine up through XE, you get to 6s2, and then my guess is that you just went straight on across to platinum. Look at the atomic numbers here, 55, 56, 57, 72. You're missing something between 57 and 72. You're missing your lanthanides. So you need to remember to go 6s2, 4f14, 5d8. Okay? So make sure that you include those bottom two sections whenever you are working. All right, so here's a picture of some of the graphics or some of the pieces of the periodic table and how it looks. There is an exception. When you are doing the group of the chromium column and the copper column, specifically these 8 elements, Cr, Mo, W, Sg, Cu, Ag, Au, and UUU, which is also known as Rg. These elements are not stable unless you do a little bit of a twist to their electron configurations. For stability, they prefer to be half full or completely full. So we liken these to thieves. We say that these elements are thieves and they steal an electron from the closest S section to fill or half fill their D section for stability. They are trying to become more stable. This applies to both orbitals and electron configurations. Here's an example. Chromium, you would expect it to be 4s2, 3d4, but because it's one of this group, the last D section will steal one of the S's and put it into its section, its D section. Okay. All right. And I'm showing you the periodic table here again. If you're looking at chromium, you can see where it would be 4s2, 3d5, or we would expect, 4s2, 3d4, but that's not what happens because it's one of the exceptions. So it becomes 4s1, 3d5. And if you do that, you still can add up your exponents and get the same end result. So take a few minutes, go back and look at the electron configurations. And remember, it links up to the quantum number rows and the quantum number orbital section letters. Okay.